Hello there fellows, today we are going to introduce Naive Bayes. So what is Naive Bayes? Naive Bayes is a simple yet effective classification algorithm based on Bayes theorem, and this is using for some simple classification tasks before the deep learning revolution. And actually it's very simple and solve problems very easily, and it's also robust in solving problems, especially in classification, in text classification. And since it's simple and robust, it's still using in some fields in machine learning field. So we can do text classification, spam detection, or sentiment analysis, or document categorization with it. So how it works? So let's look at it. This is the general formula for it. This is the only formula. So what are we doing in there? First, we will introduce our problem. Think about it. You're using email, for example, from Gmail or Hotmail or Outlook or something. So when you're using that, you have to actually, you're not have to, but your algorithm have to classify your emails as spam or normal email. So if it is spam, so it's not going to show you this email, so you're not have to handle it. This is an automatic process, but how it happens? So let's think about it. And we will define a variable a, and it represents this email is spam, and b is the email contains the word free, and when we get PAB is what we are calculating. The probability of the email is spam given that it includes the word free. So by doing these calculations, we can determine whether it's spam or it's not a spam email. So what are we doing in this calculation? As we mentioned here, PAB is the probability of A happening given that B has happened. This is what we are trying to find out. So if this email contains free word, so what is the probability of this email is a spam email? Probably it's going to be high, since many spammers using this word free. For example, you can get a free car, free stuff, something like that. So what I'm also using, PBA is the probability of B happening given that A has happened. And PA is the probability of A happening on its own, and B is the probability of B happening on its own. So we are multiplying PBA with PA, and we are dividing it to PB. This is the Bayes theorem that we are going to have PAB. So in practice, how it is working, in the training phase, we are giving a dataset into our Naive Bayes algorithm, and it's going to get the probability of each word occurring in spam and non-spam emails. For example, let's talk about the word free. So when you look at it, the free word, for example, contains in the 80% of the spam emails and 5% of the real emails. So you can easily say that if this email includes the word free, probably it's going to be a spam email, and you're going to get the probabilities of each situation, each word occurring in spam and non-spam emails. After that, in the prediction, you're going to get unlabeled email. Then the algorithm calculates probability of its being spam or not spam based on the words it contains. So it is actually using this formula in there, and after that we are going to get the, for example, average of these probabilities, and if probability is large, then we can classify it as the spam email, and it's working like that. So there are also different methods called logistic regression. Logistic regression is also a common method in classification, and it uses the functions, actual neurons, to calculate whether actually which class is the given data. So let's talk about its assumptions. Naive Bayes assumes predictor independence, but in the logistic regression, uh, there is a linear relationship between the dependent and independent variables. For example, there are a relationship between words. For example, if they say if you're actually getting an email called you are going to get a free car, you know that there's a relationship between free and car. So logistic regression can detect that. But in the naive Bayes, it's not going to detect that. It's only focus on the word free and focus on the car later. So for the performance, naive Bayes are actually very excels in the text classification task despite its simplicity. So it's a robust algorithm, and logistic regression is versatile for binary classification across various domains with insight into feature influence. When we look at the computational efficiency, naive Bayes are more efficient since it's generally faster and requires less data to train. But for the logistic regression, we have to get a lot of data to understand the relationship between these words. So it's actually harder to train. But if you have actually opportunity to train it, if you have enough computers and other kind of things, it's going to give maybe better results. You can use it for the larger data sets in the logistic regression. For the interpretability, naive Bayes is less intuitive and understanding the influence of individual features. So it's using the independence assumption, that's why it's working like that. For the logistic regression, it can interpret better than the naive Bayes because it has different kind of relationships between the input data and it affects the outcome. And also for the use case suitability, naive Bayes is preferred for high dimensional data like text. Also it can be used for the less data, like if you have 100 emails you can use naive Bayes, but if you have larger data sets, you haven't got any compute capability problems or something, you can use logistic regression and it can solve the larger problems. Thank you for listening. In the next video, we are going to have some experiments on the naive Bayes. We are going to prepare a Python code, and also we are going to solve a naive Bayes problem with our hands. So we are going to approach both theoretical and practical. So see you in next video. Have a nice day.